So, hello and welcome back. So, we are now in week 6 of this particular course, and topic for this week 6, as you have seen in the course outline, in this week we will be focusing on plastic waste management practices. So far we looked into what is plastic waste, how much is produced, what are the issues associated with that, what are the different chemicals there, how it ends up in different, whether in land, water or air. We talked about microplastics, health effect. So now all those background has been done. So now we are focusing in this particular week is what are the best practices of managing plastic waste, what are different technologies out there. And we also will talk about using plastic weights in roads, which is getting also very popular in India as well as abroad. And what are the issues and challenges with plastic waste management practices that are being used in India as well as abroad. So that will be this particular week 6. Again, as you know, we will have 5 videos of approximately half an hour each, and you will have a quiz as usual after every week. This week also you will have a quiz. So the concept will be covered is plastic waste management practices, use of plastic waste in different application including in roads, and some of the issues and challenges associated with that. So when we talk about this plastic waste, plastic, as you know, in for most part the plastic that we have to deal with is coming from the municipal solid waste. It's the municipal solid waste, the material recycling facility, which is also sometimes called as MRF, which is MRF here actually stands for material recycling facility. So there waste comes in and it gets separated into different fraction. So there are different steps here. Haulers the waste will come in, where the haulers will dump the material onto the tipping floor. Then plastic bags and other non-recyclable bulking items can't go through that system. So what will happen is screen will separate. The screen will separate the different material. Then the screen will take the cardboard using rotating disc. Smaller objects will pass through. So cardboard will get collected and taken away. Then you have a finishing screen, separates out like a 2D paper, like a paper, 3D containers. So you have a screen here which kind of removes the paper. Then you also have another screen which kind of removes the metal, so that you may use magnet to remove the ferrous. You do eddy current separators to remove the aluminum. Now after doing all that, what you left is essentially different types of plastic. So here you try to, there are different technologies out there for managing these plastics. You can use, there are what is known as static technology, there are some sensors, there are based on, you can have a density separation which will separate different heavy plastic versus the light plastic. You can also have color separation, where based on different color of plastic it will try to separate it out. More separation you can do, better the quality of the material, and you can sell that material at a better price. So as I said, the strong magnet will remove steel, eddy current will remove aluminum cans. Now the optical sorter, this is what I was trying to say, optical sorter will remove, uses cameras and sensor to separate plastic by resin code. So if you remember, we had that plastic 1, 2, 3, 4 like different resin types, which we covered in one of the earlier week, where you have the PET, HDPE and different polystyrene and different types, 1, 2, 3, 4, 5 different types of plastic. So so this optical sorter, they can remove, they can separate plastic by resin code. So that's it is done at number 7. Then after that, the glass bottles and jars are also separated. So what we are, so for the plastic waste, we are kind of looking at this particular scenario over here, but plastic waste is not in isolation. What you will see most time is plastic waste is actually part of the municipal solid waste. So this the entire process is there in terms of separating the different fraction, and this is how typical a material recycling facility or MRF works. If you get a chance to visit one, you should go and see one, and you will see most of these essentially it will have the same layout with some modification based on their local requirements that might be there. So, sorting of plastic waste, you can do density sorting as we just talked about. You can have hydrocyclones where you can use centrifugal force, enhance the material wettability. Heavy medium separation, you can use tetrabromoethane to do the separation. Triboelectric separation, which sorts material on the basis of a surface charge transfer phenomena. You can have a speed accelerators, we can paint remover, grinding and solvent stripping. So, those things are used. You can also use the optical sensor that we just talked about. So, other than the optical sensors, these are the other methods which you can use for sorting of plastic. If density, as you can see, there are some density range, not sometimes it is not too like diverse, there are a lot of overlap, because as you can see for these two has an overlap, then these two also has an overlap, and again there will be some overlap here. So, there are some overlaps. So, you will have issues of getting these two different types of plastic separated, but it does help in terms of at least doing the first round of separation, where you can have polypropylene separated out with, maybe you will get a little bit of LDPE showing there. Then you have HDPE and bulk polystyrene, polyvinyl chloride and polyethylene tetraphthalate. So, you may see some of these overlap as well, but at least it helps you to sort it out in 3-4 different fractions, and then you can go further and do other sorts of sorting there to remove the to make it more purer material. Hydrocyclone, where you can use the hydrocyclone, you can separation media and mix plastic feed. So, you can feed the stuff from here. You can this is the feeding area, this is the feeding, you can use the feed from here, and you have a hydrocyclone where low density plastic will come out on this side and the high density plastic will come out at the bottom. So, here you can have mixed plastic feed from the top, and then the low density will come out from this side and the high density will get out from this side. So, this is how you can use the hydrocyclones and to separate heavy like low density with a high density plastic waste. Gravity particle as well, like if you have heavy medium separation, you can have different feed sized particle, you put it there, then there will be some particles which will float on top, sorry. So, you will have things floating on top, and then you will have the medium fluid of so anything less than specific gravity of 2.8, you will find it on the surface. Then around 2.8 you will find in the middle, then anything greater than 2.8 you see them showing up in the bottom. So, and you can also use turboelectric separation, where you put this mixed to granular plastic from the top, this turbocharging process is there, which puts the charge, and then based on positive electrode and the negative electrode, different types of plastic gets attracted to different charges, and then you have the waste like separated out by different types based on the charge. Then you have sorting of plastic waste using sensors, which is you have an input feed, which is a speedo conveyor. This input feed is getting fed into the system, where you have this nozzle ejection spray, and this is your conveyor. So, it kind of gets blown away, it gets blown away from there as well. So, it is a dual nozzle ejection array. So, if it is a heavier, it goes to like it gets blown, if it is lighter it comes over here, based on the color, based on the sensor, different ejection is done, and then it gets transferred to another conveyor, and then finally goes into this particular pile. So, here you have the sorted fraction of HDPE, sorted fraction of PET separated out by sensor. Using the sensor, it gets separated out. So, now we will have a quick look at the different process just I talked about. We will just have a quick look at a video which kind of explains this process a little bit in more detail. So, let us have a look, and we will keep on I will try to walk you through the video as it gets you see the different process. So, here as you can see, the mixed plastic is getting loaded. So, this is your mixed plastic, the container, and then it goes into a conveyor belt, and so here overload magnet which will separate the any iron material. So, as you can see, the magnet is taking those iron material. So, anything with the iron, even iron attached to plastic or plastic attached to iron, it is getting removed. Then it goes further, and here all these plants you see lots of conveyor belt. So, you have magnetic head pulley with rare earth magnets, which is being used. It gets low magnetic iron material and iron compounds. So, even that is removed out. So, you see those which traces of. So, many times what happens, this packaging material has mixture stuff. So, that needs to be removed. So, that becomes contaminant. Now, after that you have AD current separator. AD current separator, what it does, it removes aluminum cans. So, as you can see, things gets blown away, separates aluminum parts. So, anything with the aluminum gets blown away in this AD current separator, so aluminum is taken out, so that can go as a aluminum waste. So, rest is now after removing iron, removing aluminum. So, in terms of the container system, you see the mostly now it is your plastic. So, it is a hyperspectral sensor sorter. So, this sensor sorter, what it does is it is taking out clear PET fraction. The first task it does, it tries to remove this clear PET. So, anything clear PET bottle, it is removing that, and then again it is on the conveyor belt, and it will. So, these plants you see lots and lots of conveyor belts, things just moving around. Then you have another sensor sorter. After removal of the PET, it will go for, I think, HDPE. Yes, so it will try to take natural polystyrene and HDPE fraction. So, they are being taken away. So, as so you get the HDPE and natural polyethylene. So, that those things have come in here. So, this is how things are getting sorted out. Then again it goes another round, which you will see here, it is trying to separate PP fraction, which is the polypropylene fraction. So, that is coming out as well. So, it is so different fraction. We got PET first out, we got HDPE out, now we are getting PP out. So, it helps us to separate the different fractions of plastic. Now, whatever is the remaining again goes back on the conveyor. So, as you can see, we have lots of conveyor belt on in any material recycling facility. So, again it goes through that, where it tries to take out mixed color PET. So, earlier it was clear PET, now it is mixed color PET. So, that is all it is showing up, it is getting into this particular material. Rest probably film plastics and other low quality plastic material, which is now coming out on those conveyor belts. And here it is in this particular in the sensor sorter, in this particular case it is trying to take out colored PE and colored HDPE. So, that is you see colored PE and colored HDPE coming out. So, it's so that is so we all the different fractions, and there will be some contamination, there will be some other fraction, there is some errors will be there, but these technologies are getting perfected to have minimum error. So, next sorting, as you can see, it is again going through those sorting out. Here it is taking recovered plastic fraction. So, whatever is the remaining plastic, it is just coming out there. So, this is how the sorting is done. And what you saw in this, what you are looking at this in this particular video, it is mostly it's just that container. So, it is not and it is not removing glass, paper. So, whatever is the residue now at the end, you see that drop residue, some plastic waste which was other type of plastic, some glass, paper. So, they are not recycled in this particular system, but there can be a system in place where you do that as well. So, this is how the mixed plastic is sorted out, and these kind of plants exist in many European countries, in the US and some other countries like Australia and other places as well. And so, we need to as you saw, it's energy intensive, it's mostly automatic, not much manual things were there, everything was through the machines. those machines are costly, they are not cheap. But if you look at the long term cost, as we were talking about in the previous video, towards the end of previous video, like $8 billion. So if you look at the overall long term cost, it will come out to be much cheaper when we look at the life cycle cost of not managing the plastic waste properly. And once you separate these different types of plastic, each one of those components becomes valuable. They can be recycled, they can be sold at a much better price rather than when you are trying to sell mixed plastic. Now many countries in the world is not taking those dirty plastic as well. In India too, very recently there wasn't a regulation that all the plastic solid waste import will be banned. So which is still, I'm trying to, whereas the details will come out. It was just happened in the month of early March, late February of 2019. So details will come out, and we'll know more detail what exactly it means in terms of I think it is being done as a preventive measure because of the China ban that we talked about. Because of China ban, India is becoming one of the destination for the waste, dirty recyclable waste coming from Western world to China earlier. Now it was part of it was also getting channeled to India, but this ban, I think the government has bought in to kind of prevent those dumping of those waste, those dirty recyclable. But if you follow a process like this, which you just saw in this video, you can have a clean recyclable. So if you have a clean recyclables, it can we should not have any problem accepting those recyclable, because we can easily recycle them. So that's what we should look for. So you saw that in terms of how the plastic can be separated. So plastic solid waste management in terms of managing the waste. So that was one technology, the recycling of the different, once the plastic different fraction is done, you can go on YouTube and find several videos where this can be again put into a small flakes, and you can make new bottles out of that, you can make different products out of that, which is being used in many parts of the world. So plastic solid waste management should be done in a way to reduce the pollution along the process, thereby improve the efficiency of the procedure and achieve energy conservation. So in world, if you look at the different types of management, so there is people are looking at mechanical recycling, which you saw like part of that. Even feedstock recycling, where you get it to the like a feedstock level. Energy recovery can be used for energy recovery, and when that nothing can be done, landfilling. So landfilling is the last option. Landfilling is essentially done to minimize the environmental impact, because if you look at engineered landfill, they are kind of it's a waste containment system. It's a waste containment system where you can keep the waste and try to manage it, and whatever is the leachate produced, you treat it, you collect the gas. So you are trying to control the impact coming out from the waste. It's not that much of a treatment system rather than a containment system with an environmental protection point of view. So landfill, many times people say that it's not a permanent solution, but since if no other technology is available to solve that problem, landfill at least helps in minimizing the environmental impact and controlling the environmental impact. So that's what people usually rely on landfill for that. So when we talk about mechanical recycling, we are talking we are talking about pelletizing, we are talking about extrusion, injection molding, some drawing and shredding. So that's what we are talking about in the mechanical recycle part. Then feedstock recycle, you can go for pyrolysis, gasification, waste to fuel. So that's your feedstock recycling. That's called those aspect. Energy recovery, you can go incineration, co-incineration. Then finally landfill, which is just dumping the waste in a landfill and manage the impact from there. So broadly, these are the four major ways which the plastic waste is managed or can be managed, and many times it is managed as part of the municipal solid waste. So in terms of recycling, what we are trying to do is we try to recover or reclaim the discarded waste. reprocess it, refine it to yield alternative new products. So, that is what recycling is all about, trying to make new products, maybe similar products, but new product after from the discarded waste. So, that is the whole process is recycling, and it also depends on the resin code. I am sorry, the spelling here is actually, it should be spelling should be CODE. It is a resin code, let us say typo there. So, it is a recycling of plastic mainly depends on the resin code of plastic waste. So, what is the resin code of the plastic waste? So, as you know, it is a 1, 2, 3, 4, 5 different numbers are there, which we will, I think we have a slide here as well. In few slides down the line, we will kind of revisit that to so that you can remember it. So, the top priority of waste management has always been recycling it. Not only helps us in protecting the health of the environment, but it also contributes to reuse the waste. So, therefore, like not increasing the space in landfill, it helps in keeping the landfill space low. So, we do not want to put waste in landfill, we should try to recycle it. Mechanical recycling, where you try to it's a process where you conversion of waste or scrap into a product of similar properties of the original product. So, you try to make similar properties of the original product. It involves, what you do is you recover the product from plastic scrap, you maintain the original molecular structure of the material. So, that is you do not mess up with the original molecular structure of the material. Compared to the low cost and easy glass recycling and very productive recycling of metal materials, recycling of plastic is quite challenging, because apart from several technical obstacles to overcome, they have low density and the value of the material. So, plastic recycling sometimes, other than PET, HDPE to some extent for other types of plastic, because of the low cost, and it's not that it becomes you do not get much value out of those recyclable plastic, and then it becomes a challenging from an economics point of view. So, it is quite challenging from and there are some technical obstacles which we talk about. So, if you look at the mechanical recycling, you can inspect different types of plastic, and then you try to separate it out. Then you have to, those plastics will have like some dirt associated with, there will be some things which need to be washed out. So, you do the washing as well as chopping. So, you do the washing and chopping, and after doing washing and chopping, since you washed, so it will get wet. So, you put a drying method. So, you dry it, then melt it by heat and pressure. So, after melting you after melting it, so you can filter to remove the contaminants. After it is all melted, things could be filtered out to remove the contaminant, and then whatever is the molten plastic, that can be extruded into fine strands, and after that you can pelletize it, and these pellets can be used to make new products. So, that is how typically the mechanical recycling is done. You get the source separated, you get the segregated plastic from, you saw the previous video that where the plastic was segregated out. So, this flow chart will come right after the previous video where we ended. So, you have these different types of plastics already separated out, comes in where you wash it and chop it. So, that gets there, and washing and chopping. After you try to separate by flotation different particle size as well and different density, and then you dry, because it's since it was washed, so needs drying. After drying, you melt it by heat and pressure. After melting, you use the filter to remove contaminant, and then you molten plastic, you extrude them into fine strain, and then you finally pelletize, and that pelletized plastic could be used for production of different materials of that particular similar type, or like similar type of material from the original product. So, another like a picture kind of explaining similar stuff, not that much of a difference. Again, you have the collection of plastic. So, just a illustration in a different way. You have a waste plastic being collected, what you saw in that video. So, it is kind of after that. then you sort, which was done in that video, sorting of the plastic. Then you make granules out of that, you take it, make granules, wash the granules likely to go through the wash plant, and you remove labels, residual content and soil. After wash, again you dry, as we just talked about. After drying, the granules are fed into an extruder. So, you get the extrusion done and dye in form of continuous string. Then you can use you can water cool it. The strings are water cooled and chopped into pallets by revolving receiving cutter. So, you and make it a pallet. The pallets are bagged and ready to sold to a converter who uses the recyclable or recycled material to produce new plastic products. So, this is how the whole thing works. So, this is in terms of the mechanical recycling. So, this kind of what you just in the previous slide, and plus this part is what is done in that video that we saw earlier, and then you have the other rest of the process. So, this is how the recycling of plastic is done in terms of what we know as mechanical recycling. Try to get the plastic, make the granules, so make a new product out of that. So, just another like if you look at little bit from a city level, from a city level, how it the whole system will look like. You will have consumer which will have different types of plastic bottles, plastic containers being used. They will give it to the municipality. Municipality will collect the recyclables, do the short collection, sorted waste, compressed in a bale. From bale it goes into like where you have the different types of plastic coming in. You shred it, you clean it, you make the flakes. So, if this is a PET flakes and pallets, and then those flakes and pallets can go to textile, can go to seating material, go to injection molding, goes to bottles. So, it can be used in working clothes and uniforms, can go to shirts after production of yarn and sewing and all that, and it can go into seats, which in vacuum model, into fruit trays, molding assembly can be used for stationery, and then bottles, like you have detergent bottles for the kitchen or different types of bottles. So, this is how the whole PET bottle recycling to a new business to a new product is done. It can be done. So, as you can see that the technologies again are out there. Technologies are out there which for each one of those there are even when you go on Google or YouTube, you will find several examples, several videos which kind of explains you in more detail. So, essentially what is happening here is you are taking the plastic at the municipal level, it is sorted as per MSW management rules. Then plastic is sorted separated into different types of plastic. It gets baled, goes to a plastic recyclers where it's shredded, clean, flake is made. Flake goes for either application in textile, we are talking about PET, or making sheets out of that, or injection molding, or different making bottles, and the newer product is again coming back. And this can, once it gets discarded, it will go back here, and that cycle will continue again. So, this is how it can be recycled and recycled quite a few times, and then once you cannot recycle it, of course, then it has to be managed in a different way, which we will talk about in the later videos. So, with this I think we can stop here for this particular video, and we'll continue our discussion in terms of mechanical recycling and some of the advantages and disadvantages and other stuff in the next video. So, we can potentially start from here in the next video. So, thank you for like taking this course and moving along. Don't forget to take your quizzes on time, and those of you registered for exam, I hope all of you should have registered for exam, but those of you who are just taking it the course for learning, that is also very good. So, take the quiz and then if you have any questions, let us know. We will be happy to answer through the discussion forum. So, thank you. See you again in the next video.